going to go through the awards. We have our honorees at the table here in front, and I'm going to ask them after I mention who they are to please come up and make a few remarks of their own about where they see their work going, or where they see research in general going, and how they see the GNSS industry developing. Their names and affiliations are in the programs on your table. I'm going to start with the satellites category, and this year that award goes to Martin Unwin and the Surrey Satellite Technology team. Martin is the principal engineer for SSTL, and this award recognizes his work on the Jove-A and Galileo IOV satellites and spaceborne receivers. Martin couldn't join us. He's in the UK. This is one of the first IONs he has not traveled to, but he sent his remarks, and I'm going to have to read them to you myself without the accent, unfortunately. Next on the awards list is Todd Humphreys. Todd is director of the Radio Navigation Laboratory and assistant professor at the University of Texas at Austin, and we recognize him this year as the leader of several seminal studies on spoofing and jamming. He testified before Congress this summer on the subject, and now he's going to testify to you.
Thanks, Alan. It's an honor to be here and in front of all of you GPS World guests. I think GPS World is a great glue that binds us together. It's got the latest instruction and news and gossip, and we all need that as part of a community. Ray Kurzweil, the futurist, back in 2001, spoke at a conference I attended, and maybe some of you know of Ray Kurzweil. He's variously regarded as a prophet and a crackpot. At this conference I attended, he made some bold predictions. Now, this is the same Ray Kurzweil that takes some 200 vitamins per day so that he can keep himself fit and healthy long enough that he can be alive during the singularity, at which point he's going to download his brain onto a robot and live forever. Or if not, he'll at least cryogenically freeze his head so that he can live forever later on. And so these bold predictions he made, I took note of one of them. I distinctly remember he saying that by 2011 we'll all be wearing contact lenses with a direct feed to the internet. And that by this contact lens we're going to always be online. And I thought to myself, that's nonsense. And so it was. Here it is, 2012. We don't have contact lenses quite like that. Not everybody who is wearing them. But I took note that if I were ever called upon to speak about the future, like tonight, I'd be a little bit more modest. So I'm going to make one prediction, and it'll be fairly modest. But nevertheless, it has some significant ramifications for our community. And the prediction is this. I predict that by the GPS World Dinner in 2020, we will all have carrier phase differential GPS technology on our handhelds, on our smartphones and our tablets. And for those of you who like to use an adjective for what should be a noun, that's RTK. And this is the commoditization of RTK, the commoditization of centimeter level GNSS. It will be enormously disruptive for the current industry of precise GPS or GNSS. And now you might object to this vision. You might say, wait a minute, the wretched environment that these handhelds are in and the ill placement of their antennas and the near field effects, it won't allow you to resolve the ambiguities. I recognize that. You might also object that if battery savings are most important to you, then this won't be ubiquitously adopted. I also recognize that. My students and I are working on these things. But please don't, if you're going to object, please don't make the objection that I've heard so many times. Whatever would people do with positioning that accurate? Why would they need centimeter level positioning on their phone? Because I would object to that objection. I would think of that as not imaginative enough. In any case, if you'd like to drop by tomorrow at 11:30, one of my students is going to be giving a presentation where he shows a crude box through which you can peer. And on the other side of the box you will see things that aren't there, like, for example, a sandcastle. And you can walk around the sandcastle and see it in centimeter level precision. This kind of augmented reality, I think, is going to be life-changing for many of us. And in the future, perhaps we can build it into glasses. Or even further on, maybe into contact lenses, not that I'd like to mention the contact lenses. Anyhow, thank you, and enjoy your dinner.
Yep. Thank you.
Thank you very much. This is quite an honor. I did not really expect it. And I'd like first to thank all my past mentors that helped me to gain the knowledge. And so I was able to contribute to this industry. And not in order, first of all was Professor Maurice Meyer from MIT Technology that taught me the black arts of antenna engineering. And that's how the pinwheel technology was later born in one of conferences when I had, after a few wines, some eureka experience. And also Dr. Gerard LaChapelle and A.J. Van Derendonk for insight into GPS technology, and also Philip Ward for educating me into interference and RF interference that the GPS technology is set for beacons here in Nashville too. And they've been deployed in 40 major US centers, and we hope to have a system finished by end of next year and then turn it on. It is on in the Bay Area, and the rest is being deployed. So I am conferring with my previous colleague that by 2020 you will be able to receive in your cell phones or tablets indoors and outdoors precise positioning, and that's what we're working on. The challenge is to solve the multipath and indoor propagation, and I love the challenge, so let's hope for the best. Thank you.
Thank you, Valo. And our final award in the products category goes to Robert Lupa, Chief Scientist at Symmetricom, for practical advances to overcome the intrinsic physical barriers to affordable chip-scale atomic clocks, enabling precision time and time transfer in mobile GNSS and communication systems. Robert.
Thank you, Alan. Thanks also to the committee that has selected me, and also a special thanks to whoever nominated me. Alan requested of us repeatedly and forcefully that we should keep our sentimentality to a minimum up here. But I'd be remiss if any of you left here thinking that the development of the CSAT was in any way. But having talked to all these customers, what I'm hearing is that the performance is good enough for everything they're doing with it. And what people really are asking me for is cost and battery power. And the message I have for all of them and for all of you is that cost is going to come down. The more we build, the better we get at them, and the production efficiencies go up, and the cost will come down naturally by factors of 3 or 4 in the next few years. And power also, as we're leeching onto the cell phone business, power is going to come down by a factor of 2 or so over the next 4 or 5 years. So that's my modest view of the future here. Really missing the boat here on CSAT. We've done experiments where we've shown, we've done time to subsequent fix of 15 seconds after 2 hours of GPS denial. But that's a piece of cake. Everyone knew that would work with a CSAT. But I think the really cool stuff requires getting into the code of the GNSS receiver, being able to do navigation with 3 satellites, being able to improve your nav position because your timing solution is so good, being able to do anti-spoof detection because if you know what time it is, you know if your timing solution's gone wrong. And yet we haven't seen any products since these have been out for a few years, and I'm a little disappointed that I don't see papers doing that here. And the other piece of that, I guess, is sort of the seamless co-integration of GNSS and INS, which is possible if you have a continuous source of accurate time. And I haven't seen any papers on that yet either.
Chris, Kimberly, want to cue the entrees?
Go ahead. Don't mind me.
I had a very complicated method with triangular distributions and whatnot. That A was hard to explain, and B gave the answers. I've got the spreadsheet ready. I relearned how to use Excel. Let's say for a given question, 14 tables out of 18 gave a range that bounded the solution. Now those 14 then are going to be ranked to determine the two individual scores, a score for accuracy and a score for range. Your accuracy is just based on the absolute value of the difference between your answer, not your range, but your answer, and the true solution. And as I said, it's an absolute value, so it doesn't matter if you go over or under. It's just the difference.
China to Nashville, Tennessee. I think we have some travelers who might be able to tell you from direct personal experience. Estimate the difference in kilometers from Shanghai to Nashville along a great circle global route. Wow. And from that, derive the number of Delta II booster rockets.
20,000.
We all know what?
Yeah, right? Is that what you did? 3.14 times 625?
I did 3 times 625. 1875. So I got 1875.
Square centimeters, okay.
Yeah.
But if I go with a 16-inch pizza, and I only got 1,200,
So I could be down lower range, right?
that seems kind of...
Absolute 135, lower 105, upper 155.